In this lesson, we're going to learn how to use the TI-Nspire Graphing Calculator in order to create an input and output table for an equation and then construct the graph. Let's begin by reviewing what we know. We know that we have input and output tables. In this table, input 2 produces the output 5, input 3 produces the output 6, input 4 produces the output 10, and input 5 produces the output 15. Now we're going to combine this with something else that we know. We know about graphs. We can write the inputs and outputs as ordered pairs, which are basically x and y. And then we can plot those points on the coordinate plane. When we have the input 2 and the output 5, we can write that as the point 2, 5. And we can plot that point 2, 5 on the graph. When we have the input 3 and the output 6, we can write that as an ordered pair, 3, 6. Input 3, output 6. And then we can plot that point on the graph. Input 4, output 10. That gives me the point 4, 10. And once again, I can plot that point on the coordinate plane. Input 5, output 15 corresponds with the point 5, 15. And of course I can plot that point on the graph, except, well, on my graph it doesn't really fit. In fact, my graph goes from -10 to 10 on the x-axis, which is the inputs, and -10 to +10 on the y-axis, which is the outputs. So when I'm creating a table of values, I want to look at what the valid inputs and outputs are. On this graph, my inputs can go from -10 to +10, which is the length of the x-axis. And the outputs can go from -10 to +10, which is the length of the y-axis. Now, let's get started with the graphing calculator. The graphing calculator, it turns out, is a very powerful tool. It can create an input and output table at record speeds. In fact, it makes very easy work of the job. As we go through the steps today, I ask a couple of favors. First of all, please have your graphing calculator or your computer software ready so that you can work through the problem with me. It's important that you do each step of the problem along with me so that you can get good at this process. If you need to pause the video as needed. No problem at all. If you need a minute to finish a step, just hit pause and start the video back up when you're ready. And with that said, let's begin our first exercise. Create an input and output table for each function, then construct a graph. We're given the equation y equals 2x plus 3, and we want to create an input and output table. Let's go to our graphing calculator. We turn the calculator on, go to the home screen, and then start a new document. We select Add Graphs, which is choice 2 from the menu. I see this screen right here, and you'll notice at the top, although it may be at the bottom, that I see a place to enter an equation. We have f1 of x equals. We have a place to put stuff after the equal sign. In our equation, after the equal sign, we have a 2x plus 3. We type that 2x plus 3 into the calculator. The letter x is in the alphabet keys down at the bottom. Once you've typed in 2x plus 3, you hit enter, and the graph of the equation is displayed. When we construct our graph on paper, this is exactly what it should look like. Now, we press Ctrl T to display the input and output table. Why Ctrl T? Well, table starts with the letter T. So Ctrl T will split the screen in half, showing me the graph on the left and an input and output table on the right. And that input and output table on the right is what I'll use to create my input and output table on my paper. On the paper, I'll draw a chart. I'll label the columns input and output. And then I remember the graph goes from -10 to +10. So I'll use my mouse pad to arrow all the way up to -10 on the inputs in the table. When I see the input -10, I see the output is -17. we know that the inputs and outputs on this graph can only fit between -10 and +10. -17 won't fit, so I go to the next one. I see -9, -15. The inputs and outputs only fit between -10 and +10. -15 won't fit. I'll go to the next one. -8, -13. When the input is -8, the output is -13. But -13 won't fit on this graph, so I'll skip it for now. -7, -11. -11 will not fit on this graph. The outputs can only go from -10 to +10, and so I'll skip that point. -6, -9. That'll fit. The numbers are between -10 and +10, so I write them in my input and output table, and then I arrow down to the next one. -5, -7. That'll fit. I'll add that to my table. -4, -5. That'll fit. I add that to my table. -2, -3, -3. That'll fit. Add that to the table. -2, -1. That'll fit. I'll add that to the table. And I continue adding the values that will fit on my graph. -1, 1, 0, 3, 1, 5, 2, 7, 3, 9, and then 4, 11. 11 won't fit. 11 is bigger than 10. Now next to each of these points, I'm going to have to write the XY pair so that I can plot it on the graph. And so I do that. I'm going to do input, output. Input -6, output -9 is -6, -9. I can plot that point on the graph. Input -5, output -7. -5, -7. I can plot that point on the graph. -5, -7. The next pair, input -4, output -5, is the point -4, -5. And then I plot that on the graph, -4, -5. Input -3, output -3, -3, -3. And then I plot that point on the graph. -2, -1, input and output. I plot those points on the graph. -1 input, +1 output, -1, 1. Plot the point on the graph. 0, 3. Plot the point on the graph. 1, 5. Plot the point on the graph. 2, 7. Plot the point on the graph. 3, 9. Plot the point on the graph. And now I have plotted the input and output table on the coordinate plane. Once I've plotted all the points, I connect them with a line, and I remember that the table actually went further. It continued up and it continued down. In fact, the table goes on forever. So at the ends of the graph, I place 2 arrows. That shows that the graph actually continues beyond the ends of the coordinate plane that I have on my paper. And the final step is to write the equation on the graph. The equation was y equals 2x plus 3, and so I write that on the graph. And now I've completed the input and output table for the equation y equals 2x plus 3, and I constructed the graph. In exercise 2, we want to create an input and output table for y equals x squared minus 7. Once again, let's take our graphing calculator and let's go to the home screen. Start a new document, add a graph, and you'll be brought to this screen right here. And we want to enter the equation. We have y equals x squared minus 7. So in that box, we will type x squared minus 7. If you don't recall how to put the squared in, remember that there's a key right here next to the number 4 that says x squared. If you type the x and then hit that button, it will create the squared. Now we hit enter. We see this time we got a curve. This curve is called a parabola. We're going to now press Control-T to bring up the input and output table. Our inputs and outputs can go from -10 to +10. When I go up to -10, I see that the output is far too large. In fact, the first input and output that will fit on my graph is -4, 9. Then -3, 2. And then -2, -3. And then -1, -6. And then 0, -7. And then 1, -6. 2, -3. 3, 2. 4, 9. And then the numbers become too large again to fit on my graph. Now I'd like for you to please take a moment and write the ordered pair, input, output, for each of these. Please pause the video here. Let's see how you did. Your ordered pairs look like this: -4, 9, -3, 2, -2, -3, -1, -6, 0, -7, 1, -6, 2, -3, 3, 2, and 4, 9. Next, I'd like for you to plot each of these points on the coordinate plane. Please pause the video here and plot those points. Let's see how you did. Your points should look something like this here. Now, once we have our points plotted, we will connect them with a nice smooth curve. Don't forget the arrows on the end. And then, of course, to label the equation. This shape is called a parabola. Now, let's look at an exercise that'll point out a couple of other things that are useful to know when you're constructing the graph of a function. First of all, the process for using the calculator is the same for every single problem. Enter the equation into the graph, and then bring up the table of values. Here we want to graph the function y equals -1/2 x plus 4. And once again, we go and we start a new document in our calculator. We add a graph. And on the graph screen, we're going to enter the -1/2 x plus 4. We enter that just like this. There are a couple of important notes. That negative sign in front of the 1/2 must be entered using the negative key. The negative key is underneath the 3. So you will use that negative sign and then the 1/2. To create a fraction bar, press Control, Divide, the Control button, and then the division key. That will add the fraction bar. The last piece of advice that I have for you is when you create your input and output table. When you create your input and output table, skip the numbers that are fractions or decimals for now. We're only interested in the integers. So we press Control-T to pull up our input and output table, and we go up to the input -10. Notice in this table we have some decimal values. -10, 9 is a good point, so I put that in my table. But then notice I have -9, 8.5. I'm not interested in the decimals, so I'll skip right over that and I'll go to the next one, -8, 8. And then I'll look in the table and put the next one that involves integers. Would you finish the rest of this table, please? Pause the video here and return when you're finished. Let's see how you did. Additional points: -6, 7, -4, 6, -2, 5, 0, 4, 2, 3, 4, 2, 6, 1, 8, 0, and 10, -1. The reason we skip the decimals is it's very difficult to plot a decimal on the graph. Although you could certainly plot halfway and figure out about where halfway was, we tend to stick with the integers that are easy to plot. Now, please pause the video here and write the ordered pairs x, y, input, output, for each pair. Let's see how you did. We have the points -10, 9, -8, 8, -6, 7, -4, 6, -2, 5, 0, 4, 2, 3, 4, 2, 6, 1, 8, 0, and 10, -1. Now, on the graph, would you please plot those points? Connect them with a line, and remember your arrows on the end. Please pause the video here. Let's see how you did. First, we plot each point on the graph. Then, we connect the points with a line. Don't forget the arrows on the end, and to label your graph with the equation y equals -1/2 x plus 4. In exercise 4, I'm going to let you take more of a lead on this problem. I want you to create an input and output table for y equals -x² plus 6. I want you to go into your calculator, start a new document, add a graph, enter the equation, and then pull up the input and output table. Then I want you to write the input and output table on your page. A helpful hint before you get started: remember that the negative in front of the x squared is the negative key located at the bottom of the calculator underneath the number 3. Please pause the video here and create the input and output table. Let's see how you did. Here's what the input and output table looks like. The first input that will fit on the graph is -4, -10, -3, -3, -2, 2, -1, 5, 0, 6, 1, 5, 2, 2, 3, -3, and 4, -10. Take a moment to make sure that your input and output table matches this. If it does, then go ahead and write the ordered pairs, the points that you will plot on the graph, and then plot them on the graph. Please pause the video here. Let's see how you did. Here are the ordered pairs: -4, -10, -3, -3, -2, 2, -1, 5, 0, 6, 1, 5, 2, 2, 3, -3, and 4, -10. Now you plotted the points on the graph. They should look like this right here. Is that what your graph looks like? If so, now connect those points with a nice curve, put the arrows on the end, and then label the graph. Please pause the video here. Let's take a look at your final graph. The points are connected with a nice curve, arrows were added at the end, and the equation was written on the graph. If your graph looks like this, it's perfect. Exercise 5 is for you to try all the way through. Can you create the input and output table using your calculator for the equation y equals x² minus 2x minus 8? Start a new document, add a graph, enter this equation, pull up your table of values, and then create the input and output table on your page. Then list the ordered pairs, plot the points on a graph, and come back when you've finished. Let's see how you did. We look at our input and output table. From the input and output table, I got the points -3, 7, -2, 0, -1, -5, 0, -8, 1, -9, 2, -8, 3, -5, 4, 0, and 5, 7. I carefully plotted the points on the graph and then connected them with a nice curve. Don't forget to label your graph. Now that you've gotten pretty good at creating the graphs and getting the input and output table from the calculator, let's look at an equation that has a different symbol that we haven't used before. Y equals the square root of x. The process is exactly the same. The only new step here is finding that square root symbol in the calculator, and it's actually very easy to find. We begin by starting a new document, adding a graph, And then on the graph screen, I need to figure out where to get that square root. There's a button on your calculator right here. It's between the 9 and the book. That's called the function key. And if you push that button, it'll bring up a whole menu that'll show you all kinds of different mathematical symbols. You'll see that there's a fraction bar and an exponent, and the third one in right here is the square root. So if you push that button between the 9 and the book, that function key, and then you pick this right here, it will actually put a square root right in your function. And now all you have to do is type the x on the inside, hit enter, and you get the graph. Something strange happens here. Notice when we pull up the table of values, when we go up to -1 and -2 and negative numbers further up, we get an error. That's because the function is not defined there. When you have an error like that, it means that there will not be an arrow on that end of the graph. And so when I create my input and output table, I'm just going to make a note that at -1 there's an error. And that means that there is no arrow on that end of the graph. 0, 0 is a nice point. 1, 1. And then I have some decimals. And once again, I'm not too interested in the decimal values. I'll go through to find the integers. 4, 2. 9, 3, and then after that, I'm outside of the graph. So I have only 4 points to plot on this graph. I write the ordered pairs 0, 0, 1, 1, 4, 2, and 9, 3. Then I plot the points on the graph. Now when I connect them with a nice curve, but I see that I have an important note written to myself up at the top of my input and output table, that on the negative side, there are no arrows. There's only an arrow on the other side. So I'll put my arrow there, but I will not put an arrow on the left-hand side. And then, of course, the last step, write the equation on the graph. And the steps are always the same, no matter what kind of equation I give you or how fancy or how simple it might be. All you have to do is start a document, put the equation in the graph, pull up the input and output table, list the table on your sheet, write the points, and then plot them on the graph. With these steps, you can graph any function that you would like to. That's everything you need to know to get started graphing functions using the TI-Nspire Graphing Calculator.